In this example, we'll be graphing a function and its inverse on the same xy coordinate system, and then we'll state the domain and the range of each function. So first we have f of x is equal to 2x minus 4, and I'm going to graph this function in blue. We can see that this is a linear equation, and we really only need 2 points in order to graph it, but I'll come up with a couple more points just so we can see a pattern. So let's let x equal 0. If we substitute 0 in for x, we get 2 times 0, which is 0, minus 4. That gives us an f of x value, or a y value of negative 4. Let's substitute 1 in for x. We'll get 2 times 1, which is 2, minus 4, gives us negative 2. Let's let x equal 2. We'll get 2 times 2, which is 4, minus 4, gives us 0 for the y value. Let's do a couple more. Let x equal 3. F of x equals 2 times 3, which is 6, minus 4, or 2. And finally, let's let x equal 4. F of x equals 2 times 4, which is 8, minus 4, which gives us 4. Let's go ahead and plot these 5 points on our xy coordinate system. So we have 0, negative 4. Then we have 1, negative 2. We have 2, 0. We have 3, 2. And finally, we have 4, 4. And we can see, if we connect these points, that they form a straight line. And this is the graph of f of x. Now, let's graph the inverse function in red. We'll call it f inverse of x. Now, in order to graph f inverse of x, we need to remember something about a function and its inverse. Remember, the x values, or the input or the domain values for the original function, become the range for the inverse function. And the range, or the output values for the original function, become the domain for the inverse function. Let me show you in a chart. Let me go ahead and put the x and y coordinates for the inverse function right here. So we're simply going to switch the x and the y values. So instead of having the point 0, comma, negative 4, we'll have negative 4, comma, 0. Instead of 1, negative 2, we'll have negative 2, 1. Instead of 2, 0, we'll have 0, 2. Instead of 3, 2, we'll have the point 2, 3. And finally, 4, 4, when we switch it, is still 4, 4. Now we have 5 points, and we can graph the inverse function. So we have negative 4, 0, negative 2, 1, 0, 2, 2, 3, and 4, 4. And let's connect these red dots with a straight line. And the graph in red is our inverse function, f inverse of x. So we started with our original function in blue. We graphed that. We just switched the x and y coordinates to come up with the inverse function on the graph. Now we still need to talk about the domain and the range of each of the functions, but before I do that, I want to make one point here. If you draw a dotted line, the line y equals x, right in the first and third quadrants, you'll notice that anytime you graph a function and its inverse, it's symmetric about this line y equals x, and ours certainly looks that way. So let's go ahead now and talk about the domain of our original function, f of x. Remember, it's a line, and any line with either a positive or a negative slope, in other words, it's a line that's not a special case, it's not a vertical or horizontal line, the domain is going to be from negative to positive infinity. We can let x equal any real number. And the same is true of the range. It goes from negative to positive infinity. For the inverse function, we can find that in one of two ways. in terms of the domain. We can again look at the picture of the graph in red, and we can see the domain is from negative to positive infinity. But here's another trick. The domain of the inverse function is the same as the range of the original function. So we can say from negative to positive infinity. And the range of this graph in red, again, we can look at it and we can see that it's a line and the range is from negative to positive infinity, or we could use the trick. The range of the inverse function is the same as the domain of the original function, from negative to positive infinity.